previous lectures, we have seen what are the applications of nanotechnology, what are the applications for nanotechnology in military applications, what are the military applications for nanotechnology, and we have seen military applications for nanotechnology and military applications for nanotechnology, and how the nanotechnology has imparted the commercial, how imparted the miniaturization of the devices, right? So today in this lecture, we will see how nanoscience, what is the importance of using nanoscience for R&D, research and development, right? So that is what I am Dr. Surya Sharma. So the topic name what we are going to discuss is nanoscience for R&D, research and development. So vision for nanotechnology in R&D in the next decade. So workshop should be sponsored. Workshop should be sponsored by the NSTC, Nanoscience Commission Integration Working, and group on nanoscience emerging and technology, IWGN. So group of nanoscience engineering and technology. So the main objectives is scientific technology and societal changes, challenges and trends. So US R&D activities need to realize the potential expected outcomes, input from industry, academic and government, and vision for the future, and what the national framework, and what should I do, what should we do. So promote integrity in India and university colleges collaborations in key areas, right? So this is what the vision for nanotechnology in the next figure. So organizing workshops sponsored by the Nanoscience Commission and the Nanoscience Mission, right? And the group of nanoscience and engineering and technology, and what are the objectives, and scientific technology and societal changes, challenges and trends, and US R&D activities needed to realize the potential expected outcome, input from industry, academia and government, vision for the future, a national framework, what should we do, promote integrity, India, university and government collaborations in key areas, right? In key areas. Okay. So what are the main topics? The questionnaire. The questionnaire is significant scientific discoveries last 5 years, significant technology advancement, significant technological advancement for the last 5 years, envision the scientific discoveries and applications, paradigm changes nanotechnology might bring, and how the scientific and technology infrastructure can be strengthened in the United States, and identify the priorities, right? So what research and development investments should be made in the next 5 to 10 years, and what are the implementation strategies? So these are the main topics that that exist for the development of research and for nanotechnology in research and development. That is significant scientific discoveries. So for the last 5 years, significant technological advancement for the last 5 years, envisioned scientific discoveries and applications, paradigm changes nanotechnology might bring. So how the scientific and technological infrastructure can be strengthened in the US, and identify the priorities, and what R&D investments could be made in the next 5-10 years, and what are the implementation strategies. So what is nanotechnology? In the study, exploitation of novel and improved properties, phenomena and process specific at the intermediate scale between individual molecules and 100 plus nanometers, capitalize on the ability to generate and use engineered nanostructures and devices by controlling at the atomic, molecular and micromolecular levels, right? So this is what the main important feature, right? So how to control the miniature of the devices, capitalize on the ability to generate and use engineered nanostructures and devices by control at the atomic, molecular and macromolecular levels. So unique features because scaling, interaction length, scale, engineered structures, some beyond nature, qualitative or complex and speed. So these are some of the important features what we need to study. So in nanotechnologies, why nanotechnology now? What are the requirements? Why we need to go for this type of technology? New tools allow for fundamental discoveries with the broad impact on technology, materials, biomedical, energy and environment. Revolutionary technologies are developing. Need for SE&T, scientific emerging and technology infrastructure for nanotechnology. A fresh molecular or atomic perspective in science and education. in science and education. So this is why we require this type of technology at a very low scale. So new tools allow for fundamentals discoveries with broad impact on technology, materials, biomedical, energy, and environment. Revolutionary technologies are developing. Need of S, E, and T infrastructure for nanotechnology. A fresh molecular or atomic perspective in S and E. So, what are the examples of nanotechnology? Examples of nanotechnology applications. The examples of nanotechnology application: GMR devices, giant magnitude resistance in nanocrystalline materials, right, made of hard disk heads. Key component in a disk business of over $34 billion. So 34 billions, right? And 10 years from discovery to market dominance. That is what in the case of IBM. So nano layers with selective optical barriers greater than 90% of graphic and black and white film at Kodak. So filters, cosmetic, infrared, low observable, special windows, multi-billion, and business hard coatings in construction ONR. Dispersions with optoelectronic properties, high reactivity, and chemical and bio detectors, ARO, and civilians. Advanced drug delivery systems at health pharmaceutics or $13.8 billion per year. Chemical mechanical polishing with nanoparticle slurries. New generation of lasers, nanostructure crystals in chemicals, in chemistry and fuel land, a part of 20 billions. So broad revolutionary technology, right? So these are what some of the applications of nanotechnology, right? So giant magnetic resistance in nanocrystalline materials, hard disk, a hard disk key component in a disk devices of over $34 the 10 years from discovery to market dominance. So nanolayers with selective optical observer greater than 90 degrees of graphics, black and white film at Kodak filters, cosmetic, infrared, low observable, special windows, multi-billion hard coatings in construction, dispersions with optoelectronic properties, highly reactive chemical and biodetectors. So advanced drug delivery systems and chemical mechanical polishing with nanoparticles slurries. So examples of nanotechnology applications part 2. So systems on a chip. Examples: NASA thin film batteries, nanopixel sensors for low power consumption, carbon nanotube products, reinforced materials, probes, connectors or transistors, nanoparticle reinforced materials, thermal barrier, inkjet systems, nanoparticle pigments, information recording layers, molecular sieves, high hardness cutting tools. And these are some of the examples of nanotechnology for different applications. So suggested organization of the report: basic R&D topics, fundamental issues, computational methods, experimental tools, synthesis and processing, societal impact. Area of relevance and application: dispersions and coatings, nano devices and nanoelectronics, consolidate nanostructures, biological, medical and health, energy and environmental applications. Conclusions and priorities: infrastructure needs, agencies, funding strategies, scientific, technological and organizational priorities in the next decade. So these are some of the suggested organizations of the report. Conclusions and priority: infrastructure need, agencies, funding strategies, right? So what are the major themes? Scientific and engineering frontiers at nanoscale, fundamental research and discovery at the interface among physics, chemistry, biology and engineering. Examples: new properties and phenomena, nanoscale synthesis and assembly by design, nanobiotechnology, functional engineering at nanoscale, theory, modeling and simulations. Create a balanced infrastructure for nanoscale science, engineering, technology and human resources in the field. So education revolutionizes connections between physics, chemistry, biology and engineering in education, and education from elemental postdoctoral fellows. Right. So these are the major themes: scientific and engineering frontiers at nanoscale, fundamental research and discovery at the interface among physics, chemistry, biology and engineering. Examples: new properties and phenomena, nanoscale synthesis and assembling by design, nanobiotechnology, functional engineering at nanoscale, theory, modeling and simulations. Create a balanced infrastructure for nanoscale science, engineering, technology and human resources in this field. Education revolutionized connections between physics, mathematics, biology and engineering in education. Education from elementary postdoctoral fellows. So what are the activities in Nano's mission before 1998? Within disciplinary programs, MB 40M plus Engineering 20 plus Bio 5 and CSC 2M plus and SBM. Advanced Materials and Processing Programming, including nanostructures, molecular self-assembly, chemistry, etc. Ultra-fine particle engineering, synthesis at highest rates. And National Nano Fabrication User Networks, a focus on electronics extending MEMS to top-down approach. Several other centers, right? Several other centers, ERC's examples, 3 particle at Pennsylvania State University and MRSEX and U of Winscom JHUS. Nano 95 for nano instrumentation acquisition plus development. Education opportunities in centers. Collaboration with industry, young researchers to Japan and Europe, right? Sites at course modules. So nanoscales. So initiatives and funding opportunities for nanotechnology. So small groups for functional nanostructure solidification with deadline on February 17, 1998. So National Nano Fabrication User Network. Okay, 4-year level evaluation in 1998. New MRSEX, UK, Columbia. So STTR, Small Business Technology Transfer, Solidification of Nanotechnology, issued in July 1998. Deadline is December 14. Exploratory research on biosystems at nanoscale at 1999. Continue individual programs in MPs in math physics, chemistry, English, biological, computer science and SB centers, and in open competition and goalie participation education. Nanoscale science and technology in an area highlighted in NSF budget for the year 1988 to 1999. So what is the synthesis, processing and utilization of functional nanostructures? So synthesis processing and utilization of functional nanomaterials. Focus on generation. Generation means nanoparticles, nanoplates, tubes, biomaterials, self-assembled systems, processing, use, modeling and simulation of functional nanostructures. Small group up to 4 principal investigators. Collaborations with industry, other universities and agencies up to 2 proposal per institution. Awards 300 Kelvin to $7,000K, so 3,000K to $7,000K over 3 years, and $13 M in financial year in 1998, and 24 awards, 25% of Guli, interest 37% other agencies. On this, so this information was taken from the website www.nsf.gov.nano. So partnership on nanotechnology for the financial year 1998 awards. So 178 proposals, 24 awards, average award $540 for 3 years. Supported projects, biostructures, macromolecules, self-assembling 5, and inorganic 6, nanoparticles or layers or tubes 5, electronics and electro-optics 4, devices and instrumentation 4, new research directions, that is nanorobotics, biomaterials, develop infrastructure for discovery at nanoscale, right? So these are some of the partnership of nanotechnology for the financial year 1998 awards. Okay. So 178 proposals or 24 awards, average award around $540 per 3 years. Supported projects, biostructures, macromolecules, self-assembling 5, inorganic 6, nanoparticles, layers and subtubes, electronics, electro-optics, devices and instrumentation. So new research direction, nanorobotics, biomaterials, develop infrastructure for discovery at nanoscale. So what are the examples? Simulations and experiments on the electronic confinement, optical gap in quantum dots. So simulation and experiments of crystallization confinement, water at minus 30 degrees and 10K bar, 2-dimensional structure, new phenomena, elastic chain behavior of inorganic particles, that is what UCLA. So biomimetic carpentry of self-assembling proteins, nanostructures based on tail fiber, that is 2.5 nanometers there. Various building blocks by design, NNUM, MREC, ERC, education, University of Wisconsin, Yale University, and from NSF 98 to 20, nano motors, nanorobotics, and reinforced materials of it. What is the new research opportunities in this new nanotechnology? So new phenomena, properties and process, interface with biosynthesis approaches, bio-nanostructures, biomedicines, theory and simulation techniques for predicting synthesis and behavior of clusters, multifunctional or adaptive nanostructures, time-effective, economical, high-rate production and manufacturing methods. Overall, the confluence of science of building tailored blocks of atoms and molecules and engineering assembly and use of those building blocks into functional nanostructures, broad enabling tool. That is what the tool. That is what the new phenomena, properties and process interface with biosynthesis process approaches and bio nanostructures, biomedicine theory and simulation techniques for predicting synthesis and behavior of clusters, multifunctional adaptive nanostructures, time-effective, economical, high-rate production, manufacturing methods. Overall, confluence of science of building tailored blocks of atoms and molecules and engineering, assembly and use of those building blocks into functional nanostructures, broad enabling tool. So these are some of the examples what we can see: simulations and experiments on electronic confinement, electronic gap in quantum dots. So simulation experiments of crystallization confinement. So new phenomena, elastic chain behavior of inorganic nanoparticles and biometric carpentry of self-assembly proteins and various building blocks by design. And partnership on the 1988 awards was for inorganic 6 nanoparticles layers or tubes 5 and 5 particles electronics or electro-optics 4, device and instrumentation 4. New research direction, new nanorobotics, biomaterials, develop infrastructure for discovery at nanoscale. So simulation experiments on electronic confinement, optical gap in quantum dots. So simulation and experiments of crystallization confinement, new phenomenon, elastic chain behavior of inorganic particles, biometric carpentry of self-assembling particles, nanostructure based on tile fiber, various building blocks by design, and NNUN, MR, SEC, ERC, Education, MBSCON, Yale University. So these are the new opportunities in nanotechnology. So new phenomena, research properties and process and interface with biosynthesis approaches, bio-nanostructures, biomedicine, theory and simulation techniques for predicting synthesis and behavior of clusters, multifunctional or adaptive nanostructures, time-effective, economical, high-rate productive manufacturing methods, and overall confluence of science of building tailored blocks of atoms and molecules and engineering, assembling and use of those building blocks into functional nanostructures and broad enabling tool. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.